I challenge you to a game of rock, paper, scissors, shoot. Rock, paper, scissors, shoot. Rock, paper, scissors, shoot. Rock, paper, scissors, shoot. Notice any patterns? At first, my strategy may have worked really well, but the longer I rely on just that strategy, the easier it will be for you to adapt your strategy to beat mine. The same phenomena has been happening on farms across the United States. Where farmers have been overly reliant on one singular herbicide, weeds have now developed resistance, meaning they are no longer killed by that herbicide. The amount of corn, soybean, and cotton acreage sprayed with glyphosate to manage weeds in the U.S. has been increasing since the late 1990s, and today 95 to 97% of those fields rely on glyphosate. Subsequently, there are now 263 species of weeds that are resistant to glyphosate worldwide. And with so many weeds resistant to the primary tool farmers use to eradicate their weeds, farmers are really beginning to struggle to manage all the weeds on their farms. But what if we changed our strategy, or better yet, created a new way to manage weeds? The more weeds I have and use, the harder it will be for you to predict what moves I'm going to use next. So that's why my lab is studying new ways to control weeds that are not just herbicide-based. One way we're experimenting with managing weeds is through reducing the available nitrogen. Most weeds that grow in agricultural fields love high nitrogen soils. So by reducing the nitrogen, those weeds don't grow as well. One way to do this is by promoting soil microbial growth. When soil microbes grow, they immobilize nitrogen, which means that they incorporate nitrogen into their cells. If you can visualize crops struggling to grow where there are a lot of weeds, it's kind of similar. Some weeds can actually struggle to grow where there are a lot of soil microbes because they use the same resources. The way we're promoting soil microbial growth is by adding carbon to the soil. Carbon is the limiting nutrient for the soil microbial community, which means it is a nutrient that is preventing more growth. So when we add a substance that has a high percentage of carbon, such as sawdust or sugar, the soil microbial community grows. And as it grows, the microbes eat more of the soil nitrogen. As they eat up that nitrogen, they immobilize it. And weeds, which also really needed that nitrogen, can't access it, so they don't grow as well. We found that this strategy can dramatically decrease weed species growth. Here we have a pigweed, which is a common agricultural weed, with a 10-fold decrease in growth just by adding carbon to the soil. Some crops also don't grow as well because they also need nitrogen. But other crops, such as soybeans, can capture their own nitrogen from the air. So these crops grow really well even when there is less nitrogen available in the soil. Hopefully we can refine this strategy well enough for farmers to use it on their soybean fields as an alternative to glyphosate. Having these extra weed control tools makes it harder for weeds to anticipate the farmer's next move. If I were going to challenge you to another round of rock, paper, scissors, shoot, this time I might try a different strategy, and this time I might actually win.